Welcome to this DSAT Math Module 2 lesson. Today, we're going to solve a problem involving quadratic functions. Here's the problem. Find the value at t equals 0, which is March 1st, assuming the quantity follows a quadratic curve, whose maximum occurs at t equals 3.5. Let's start by identifying what we know. We're told that the maximum value of the function occurs at t equals 3.5 with a value of 13.92. At t equals 5, the value is 13.47. We need to find the value at t equals 0, which corresponds to March 1st. We'll solve this problem using two different methods. First, let's use the vertex form of a quadratic function. A quadratic function in vertex form is written as f of t equals a times the quantity t minus h squared plus k. Here, the point h, k represents the vertex of the parabola. Let me illustrate what this means. Since we know the vertex is at t equals 3.5 with a value of 13.92, we can substitute h equals 3.5 and k equals 13.92 into our vertex form. This gives us f of t equals a times the quantity t minus 3.5 squared plus 13.92. Now, we need to find the coefficient a. To find a, we'll use the additional information that at t equals 5, the value is 13.47. Substituting t equals 5 into our equation, we get 13.47 equals a times the quantity 5 minus 3.5 squared plus 13.92. Simplifying, we get 13.47 equals a times 2.25 plus 13.92. Now let's solve for a. Subtracting 13.92 from both sides, 13.47 minus 13.92 equals a times 2.25. Calculating 13.47 minus 13.92 gives us negative 0.45. Dividing both sides by 2.25 equals negative 0.45 divided by 2.25, which equals negative 0.2. Great. Now we have the value of a, which is negative 0.2. Substituting this back into our vertex form, we get the complete quadratic equation. F of t equals negative 0.2 times the quantity t minus 3.5 squared plus 13.92. This is our quadratic model in vertex form. Now we can find the value at t equals 0, which corresponds to March 1st. Substituting t equals 0 into our equation, f of 0 equals negative 0.2 times the quantity 0 minus 3.5 squared plus 13.92. Let's evaluate step by step. First, 0 minus 3.5 equals negative 3.5. Next, negative 3.5 squared equals 12.25. Multiplying by negative 0.2, negative 0.2 times 12.25 equals negative 2.45. Finally, adding 13.92, negative 2.45 plus 13.92 equals 11.47. Therefore, the value at t equals 0, or March 1st, is 11.47. Now, let's solve the same problem using a different approach, quadratic regression. First, let's observe something interesting about quadratics. Due to the symmetry of parabolas, points that are equidistant from the vertex will have the same y value. Since t equals 5 is 1.5 units to the right of the vertex at 3.5, the point at t equals 2, which is 1.5 units to the left, will have the same y value of 13.47. So now we have 3 points on our quadratic curve. The point 2, 13.47, the vertex at 3.5, 13.92, and the point 5, 13.47. With these 3 points, we can find the equation of our quadratic through regression. Let me show you how this would look in a graphing calculator like Desmos. In a real calculator or spreadsheet, you would input these 3 points and the software would perform a quadratic regression to find the best fitting parabola. This would give us the same equation we found earlier. F of t equals negative 0.2 times the quantity t minus 3.5 squared plus 13.92. The calculator might show this in standard form as f of t equals negative 0.2t squared plus 1.4t plus 9.03. Let's verify our answer by evaluating the function at t equals 0 using the standard form. Substituting t equals 0 into f of t equals negative 0.2t squared plus 1.4t plus 9.03. F of 0 equals negative 0.2 times 0 squared plus 1.4 times 0 plus 9.03, which simplifies to 9.03. Wait, that's not right. We got 11.47 earlier. Let me double-check the conversion to standard form. Let me recalculate the conversion from vertex form to standard form. Starting with f of t equals negative 0.2 times the quantity t minus 3.5 squared plus 13.92. Expanding the binomial, t minus 3.5 squared equals t squared minus 7t plus 12.25. Multiplying by negative 0.2, negative 0.2t squared plus 1.4t minus 2.45. Finally, adding 13.92, f of t equals negative 0.2t squared plus 1.4t plus 11.47. Now, let's verify our answer with the correct standard form. Substituting t equals 0 into f of t equals negative 0.2t squared plus 1.4t plus 11.47. F of 0 equals negative 0.2 times 0 squared plus 1.4 times 0 plus 11.47, which equals 11.47. This matches our earlier result. The value at t equals 0, or March 1st, is indeed 11.47. Let's summarize what we've learned. We solved this problem using two different methods. 1. Using vertex form. We identified the vertex coordinates and found the coefficient using a known point. 2. Using quadratic regression. We used 3 points to determine the quadratic equation. Both methods gave us the same answer. The value at t equals 0, or March 1st, is 11.47. Remember, for any quadratic function, the vertex form f of t equals a times the quantity t minus h squared plus k is often the easiest way to work with when you know the coordinates of the maximum or minimum point. Thank you for watching this DSAT Math Module 2 lesson. I hope you now understand how to work with quadratic functions and find values at specific points using different approaches.